Fine. Now we will discuss about the 1 minute, please. Yeah. That. So now we will discuss about the simple linear regression model. So the simple linear regression model is used to work on regression problems. So regression problems means in the problems in which your output variable is continuous number format, like temperature prediction, load prediction, weather prediction, price prediction, ice cream sales prediction. Such type of predictions are comes under the here the simple linear regression model is used. Simple linear regression model is used to work on the regression problems. In the simple linear regression model, especially used one input, one output problems, like you are trying to predict one variable based on one single input variable. That means you have the one single output variable, you have the single input variables. So based on one parameter, you are going to predict other parameter. So that means only one input and one output. Then we will go for the simple linear regression model. It is very, very basic model. So that means, so let's assume this is the linear regression model, simple linear regression model. So you can remember one thing, every machine learning model is nothing but the some mathematical process inside it. That's it. Machine learning model is nothing but the model with some mathematical process inside. Okay. That mathematical process, I want to open it. So when you are working with only libraries from the Python, then you can't understand what happened inside. So in this session, I want to open it. What will be inside your simple linear regression model? So as I said, your simple linear regression model is used based on the one input and one output. That means you want to predict one output Y based on the one input feature X. For example, I want to predict the load on a substation, next hour load on a substation based on the previous hour load. That means my input is previous hour load, which is available. I am trying to predict the next hour load. That is my output. The one input and one output. So that in such cases, you may go with the simple linear regression model. One input and one output. Hope you understand what I want to convey with you. If in other case, suppose if you want to predict the price, energy price in the market for tomorrow, 6 o'clock, based on the price available today at 6 o'clock. That means today 6 o'clock price is my input. Based on today 6 o'clock price, I want to predict the load in the next 6 o'clock. And that means tomorrow 6 o'clock morning. Okay. Right. So that's the one input and one output. So in such case, we can go for the simple linear regression model. So X is your input and Y is called as YP. I will write YP is called as the predicted output by your simple linear regression model. So this is the simple linear regression model. Simple linear regression model. Okay. So what is inside? What is inside your simple linear regression model? The name itself says that linear. It's a linear. So linear means there is some linear relation will be established inside your simple linear regression model. A linear relation is established between your output and your input in the linear format. So what is that one? So the inside is it will be like this M. Okay. And here you have the plus and plus. Here you have the bias parameter that is called as the C. That is called as the C. So M and C are called as the model parameters of your simple linear regression model. This is the plus, both are plus, okay? And this is coming to the here also. So this is the inside your simple linear regression model. So that is inside your simple linear regression model. Okay. So this is the mathematics behind your simple linear regression model, that mathematical process or mathematical relation that establishes between your x and y, your input and output. So from here you can write yp, that means predicted output by the simple linear regression model is equal to m, that is the one model parameter, into your input x plus bias parameter c. This is how your simple linear regression model will work. Okay, so this is the simple linear regression model. Now we have to feed the data. What data we have to feed? You have to feed the input data, and also you have to feed the output data y. Yp is the predicted output by your simple linear regression model. Y is the actual output. I said right yesterday. So you have to provide both input variable and output variables in case of the supervised learning. So in the simple integration model, we are using the supervised learning. In the supervised learning, you have to give your inputs X data, and also you have to give your outputs Y data. You have to give a huge number of samples. You have to provide. You have to provide a large number of samples. You have to provide the data of large number of samples. You have to provide, like x1 output is y1, when x2 output is y2, and x3 output is y3, and x4 and y4 is y4. So like that, so on. So like that, hundreds of samples of data you have to prepare. And based on the samples of data, so this is the sample 1, this is the sample 2, this is the sample 3, and the sample 4. Like that, you have the 100 samples of data. And this data will help your machine learning model to update the model parameters M and C, in order to predict the output YP based on your input X. Your output should be very close as possible to your actual value. Y is the actual output, YP is your predicted output. Y is called as your actual output, where YP is called as your predicted output. Okay. Right. So now, so how it will work, how your model parameters will work. So how your model will learn, that we will discuss. Okay. Now see, let's assume I am giving the one input x1. I'm taking the first sample, and the input of the first sample equal to x1, and the output of the first sample equal to y1. That is the output of the first sample. Okay. Now what happened? The x1 is multiplied with m. So x1 is multiplied with m, and C will be added. That will be your YP value coming outside your machine learning model. That is coming outside your machine learning model. Now what we will do? We will compare what machine learning model is predicting, what is the actual value it is. What your model is predicting, what is the actual output value it is, and compare these two, and we calculate the error. So here we are using the of square error or of mean square error. We are using the of mean square error. So first see what's called error. How we calculate error? Error is nothing but your predicted output minus your actual output. Predicted output or minus actual output. Okay. And and square error, that means you have to make it square. You have to make it square. Square error, that is you have to make it square. You can keep y minus yp, or you can take yp minus y. So whatever it may be, you can consider. Okay. So this square error and mean square error means sigma I equal to 1 to n, where I equal to 1 to n means number of samples. We have to pass the first sample x1 and output is y1, calculate the square error, and calculate the second sample x2 and y2, calculate the square error. Pass the third sample x3, y3, calculate the square error, and add all and make mean 1 by n. This is a mean square error. I think you agree. It is a mean square error. So after calculating the mean square error, what is this one? Half mean square. Half mean square means 1 by 2. 1 by 2. So this is the error. I am representing as a error. Error equal to 1 by 2n integral I equal to 1 to n y minus yp whole square. So I want to note it down here. My error equal to, after passing all the training data, my error equal to 1 by 2n sigma I equal to 1 to n y minus yp whole square, where yp equal to m into x1 plus c, where yp equal to m into x1 plus c. Okay. So this is the error. Now, what it will do based on this error, based on your actual value and predicted value, based on this error, you are going to update your model parameters. You are going to update your model parameters M and C. Your model parameters M and C in such a way that your error should be minimum. That's right. So machine learning, nothing but updation of the model parameters of your machine learning model in such a way that your model is predicting the value close to your actual value. That means error should be minimum. Okay. So your model parameter should be updated. Your M and C value should be updated in such a way that your model predicted YP value so close to your actual value Y. Then the error will be minimum, so that your model parameters are updated in such a way that your error will be minimized. That's why minimize this error. See, actually, it is like a machine learning, but we are coming into the optimization problem. Now, to optimize, to minimize this error function, it is a non-linear, right? A square term. It is a non-linear, right? So because it is a non-linear, it is a square term, and we are trying to minimize it. So this is the example for the non-linear optimization problem. So to solve this non-linear optimization problem, what we will do? We are trying to use the gradient descent algorithm. Gradient descent algorithm. In the gradient descent algorithm, there is a one algorithm, one variant is called as the stochastic gradient descent algorithm. So if you use the stochastic gradient descent algorithm, I will explain with respect to the stochastic gradient only, not remaining. In case of the stochastic gradient descent algorithm, in case of the stochastic gradient descent algorithm. So what the stochastic gradient descent algorithm means, the model will be updated sample by sample. We are not passing all the samples at a time. We will pass the first sample, calculate the error, and update the model parameter. Next, pass the second sample, calculate the error, and update the model parameter. Pass the third sample, calculate the error, and update the model parameter. For every time, we are passing only one sample. In case of the stochastic gradient. So in such case, what will be the error function for your simple linear regression model in case of the stochastic gradient descent optimization algorithm? E equal to 1 by 2, n equal to 1, right? Because we are passing only one sample at a time. So 1 by n equal to 1, I equal to 1 to n. That means only one part. So into y minus yp whole square. So this is the error function if you are using the stochastic gradient descent algorithm and you are trying to minimize this error function. Minimize the error function is nothing but the minimize the difference between the actual value and predicted value. Nothing but the you have to provide a proper machine learning model so that the model will be able to predict with a value which is close to your actual value. The value is close to your actual value. Okay. So this is equal to how we can write 1 by 2 into y is called as the actual value minus yp. What is the yp value? So yp value equal to mx plus c. That means m into x plus c means it's a minus, right? So minus mx minus c whole square. So this is my error function, and I am trying to, my optimization algorithm will try to minimize this error function by updating the model parameters m and c, where x and y are called the input value and output value from the data set. X and y values are, y and x values are input and output values from the data set, where m and c are called as the model parameters. So m and c are called as the model parameters. Where x and y are called as the input value and output value from the data set. The x and y values are coming from the data set, and m and c values are the model parameter. We are going to update the model parameters m and c in such a way that my error will be minimum. in such a way that my error will be minimum. Right? My error will be minimum. Okay. Now, so now it's like a minimization of the an objective, minimization of the error function, minimization of the cost function, minimization of the objective function. So we have to go for the optimization techniques. So I want to use the gradient descent algorithm. Again, we discussed earlier. Now we are trying to minimize this part. Okay. Now we will discuss how gradient descent algorithm will help to update the model parameters. Okay. Clearly understand, clearly see here. Let's assume I want to predict the load at a particular time on a substation based on the load available at 1 hour before. So one input and one output. Based on this input, and I want to predict the next hour output. Based on the previous hour input, I want to predict the next hour output. Now I went to a substation and I collected the data and rearranged the data like this. So I have the values like x1, x2, x3, x4, and similarly here we have the y1, y2, y3, and y4. Data is prepared. This is the output and this will be the input. Right? Fine. So how now we will discuss about the gradient descent algorithm. Now we will discuss about the gradient descent algorithm. So step one is so you have to read the data. Read data. So your data contains. So I want to call this previous hour load data as a x, and I want to call next hour load data as a y for easy representation only. So read the data x comma y. X is nothing but the previous hour load data, and y is nothing but the next hour load data. So in addition to that, you have to read this one. Okay. And also you have to mention epochs, number of epochs you want to run this algorithm. You have to remember how much number of epochs you want to, you can tell. You can give those number of epochs. Okay. Now, first tell me before going to algorithm. So I will separate it like this. So what is my error function? I want trying to minimize error function E equal to 1 by 2 into y minus mx minus c whole square. That's what we developed. Where y and x are coming from the data set. M and c are the model parameters. E is m, so your error value is mainly depending upon the model parameter m and model parameter c. These are called as the decision variables. Previously, we solved the problem f of x equal to x square plus 5, f of x comma y equal to x square plus y square plus 10, where x and y are the decision variables. Like this, here my objective function is error. My decision variables are m and c. My decision variables are m and c. My decision variables are m and c. Okay. So tell me, so what is the first step now? As per a gradient descent algorithm, our first step is I am reading the data, number of epochs initialized. Now you have to initialize your m and c values. You have to initialize your m and c values. You have to initialize m and c values, right? You have to initialize the eta also. In the gradient descent algorithm, we require eta. Learning rate also we required. That also initialized. Right? What else? Anything else we have to initialize? And also you have to initialize the number of samples. So you have to initialize n. N is nothing but the number of samples in the data set. Initialize the n, that is called as the number of samples in the data set. In this case, number of samples n equal to 4. For in our example, number of samples n equal to 4. N is different, eta is different. Okay, fine. N is the number of samples in the data. Eta is the learning rate. M and C are the initial values of the M and C. And epochs are the max number of epochs, max number of iterations you want to run the data. You want to run the algorithm. So what is the step 2? What is the step 2? In the step 2, we have to set first iteration. And in the step 3, you have to take the first sample and later second sample, later third sample, later fourth sample. Take the first sample, update the model parameter. Take the second sample, update the model parameter. Take the third sample, update the model parameter. Take the fourth sample, update the model parameter. Then one iteration is completed. So training algorithm for the 100 iterations means you have to take we have the 4 samples in our data, let us assume. Take the first sample, update the model parameters M and C. Take the second sample, update the model parameters M and C. Take the third sample, update the model parameter M and C. Take the fourth sample, update the model parameters M and C. This process should be repeated for every iteration. Okay. So what is the step 3? You have to take sample number, sample equal to 1 means take the first sample. We are taking the first sample. Okay. Now, step number 4. So now tell me what we are trying to do. So generally, if we want to if you want to solve this problem using the what's called gradient descent algorithm, what we will do generally, there are the 3 steps we are following. Step number 2, step number 3, and step number 4. I think you agree. Step number 2. In step number 2, what the step number 2 we are following? We need to calculate the gradient with respect to the decision variables. Here we have the 2 decision variables. One is the GM and another is the GC. 1 minute, please. So 1 minute, please. Please. It is still loading. Oh, no, no. Okay, done. Sorry. So if you want to minimize this objective function using the gradient descent algorithm, what we will do? We will try to calculate the gradient with respect to the decision variables or the model parameters. What are the decision variables here? M and C. So calculate the gradient with respect to the model parameter M, GM, and gradient with respect to the model parameter C, GC. Okay, so what is the GM value? How we calculate GM value? That means first order differentiation of this error, dou E by dou M, and here it is a dou E by dou C. So that's equal to, so 2 come forward, 2 will be cancelled. Then you have the Y minus MX minus C. And we are differentiating with respect to M. What is the M coefficient? Minus X. So it is X and minus. Similarly, GC you have to calculate. GC nothing but the dou E by dou C. That means differentiation of the error function with respect to the C. what happened? These two come forward, 2 will be cancelled. Then you have the y minus mx minus c, and the c coefficient is -1. So minus you have to keep here. You have to keep c here. Okay. And next one is, after calculating the gradients, what is the step number 3? Step number 3, what we will do? We will calculate the step length, right? Delta x and delta y. Here we are to calculate the delta m and delta c. That is the model parameter step length. So delta m value equal to, what is the delta m value? That is the minus eta into gm, dou e by dou m. Similarly, delta c equal to minus eta into gc. These things we discussed in the previous session, right? So that's why minus eta multiplied by gm, then you have the eta into y minus mx minus c into x. And here gc equal to eta into y minus mx minus c. So you have to calculate the step length, delta m and delta c. Once it is calculated, now go to the step number 4. Step number 4, you have to update the model parameter. You have to update the decision variable values. That is the m equal to m plus delta m and c equal to c plus delta c. And these 3 steps are repeated. Same. For every iteration, you have to, for every sample, you have to update the model parameters like this. You have to update the model parameter like this. Okay. So if you understand this part, now coming to our step-by-step process. Gradient descent algorithm to update the model parameters of the simple linear regression model. In the simple linear regression model, we have the only 2 model parameters. One is the m, other is the c. Now, what is the step number 4? So step number 4 means these 3 will be counted. So, okay. So in the step number 4, we have to calculate the gm and gc values. So we calculate gm. In the step number 4, you have to calculate the gradient gm equal to minus y. Y is nothing but the actual output that is coming from this data set, minus m, that is, or the m value we are already initialized, that m into x. X is coming from this data set again, minus c. C is already initialized, multiplied by your x. That x is again coming from the data set. Similarly, calculate the gc, that's equal to minus y minus mx minus c. That's it. So y and x are available from the data set. M and c are initialized already. So after calculating the gradients gm and gc, now we are going to calculate the step number. Go to step number 5. Go to step number 5. So in the step number 5, how we do the step number 5? What we will do in the step number 5? We are going to calculate the step lengths, delta m and delta c. So calculate the delta m equal to, how we calculate delta m? Minus eta, minus eta is already initialized, eta. So minus eta multiplied by minus eta multiplied by gm. Already gm calculated the step number 4 into gm. Similarly, delta c equal to minus eta multiplied by gc. Multiplied by gc. Okay. So we calculate the delta m, gc and delta m, delta c. Now go to the step number 6. So what we will do in the step number 6? That nothing but step number 6 means here it is the 4th step. So m equal to m plus delta m, c equal to c plus delta c. We are going to update the model parameter m equal to m. This m is coming from the initial value, plus delta m is coming from the step number 5. C equal to c plus delta c. C is coming from this initial value. Delta c is coming from the step number 5. Okay. So actually these are 3 steps. These 3 steps are repeated again and again. So what is the next step? Step number 7 here. So you have to update your sample number. Sample equal to sample plus 1. Because we are taking the first sample, that means we are taking the x1, y1. Now we have to update the sample number. Now sample equal to. Now take the second sample. Take the second sample. Now what we will do? Step number 8, what we have to do? We will check whether the current sample number is greater than the total number of samples or not. If it is greater than total number of samples, means all the samples in the data is covered. Then go to the next iteration. Okay, now if it is true, go to next step. Suppose if it is a false, what we will do? That means sample number is not greater than n. It is equal to n or less than n. That means still few samples are there. in order to update your model parameter. Then what you have to do? Then you will directly go to the step number 4. Go to step number 4. What you will do? Go to step number 4. Based on the updated sample number, you have to calculate the gradients, calculate the step lengths, and update the model parameters. So this process will be repeated. Okay. And next one is step number 9. Next step is step number 9. What you will do here? That means if sample is greater than n, that means you covered all the samples available in the training data. All the samples are covered. Based on all the samples, you are updated the model parameter. Then what you have to do? Go for the next iteration. Iter equal to iter plus 1. Next iteration. This step number 9. Now go to the step number 10. Go to the step number 10. So in the step number 10, what we will do? Check whether your current iteration number greater than number of epochs, max the number of epochs you initialized at the starting of your algorithm. So if it is a true or if it is a false, there are two possibilities. If it is a true, that means your iteration number is greater than max the number of iterations you mentioned at the time of the initialization, then go to next step. Otherwise, if it is a false, that means the current iteration value is not more than the number of epochs that you initialized at the time of the first iteration, sorry, starting initialization. Then what you will do? So if the current iteration is not going, not more than your number of epochs you initialize, then go to again step number 3. Again go to step number 3. Again start from the sample 1, sample 2, sample 3, sample 4. Hope you understand. For every iteration means every iteration will be start from the first sample. Later second, later third, later fourth. If all the samples are covered, then go back to the second iteration. Again, starting from the sample 1, sample 2, sample 3, sample 4. Again, go back to the third iteration. Same thing will be repeated until you reach the maximum number of iterations you mentioned at the time of the algorithm. Okay, so if the number of iterations is not more than the number of epochs, then go to the step number 3, again start from the sample 1. So go to step number 3, again start from the sample 1 and calculate the gradient, calculate the step length and update the model parameters, all the things you have to complete. And finally, step number 11. So step number 11 means you will get finally, the algorithm is finished. So what you have to do? You have to print your final model parameters. You have to print your final model parameters and calculate your training error and also give the testing data and also calculate the testing error. So error is nothing but the difference between the what your model is predicting YP and what actual output is Y. The difference between these two is called as error. So you have to calculate the training error based on the training data. You have to calculate the testing error based on the testing data. Okay, so this is the complete process or algorithm using the gradient descent algorithm to update the model parameters of the simple linear regression model. Simple linear regression model. Okay, so we will discuss implementation of a simple linear regression model from the scratch, like a gradient descent algorithm, and also we will discuss using the Python libraries as well. Both things we will discuss today. So I think you are clear with the algorithm, how gradient descent algorithm will help the simple linear regression model to update the model parameters M and C based on the data available X and Y. Based on the data available X and Y. Right? So I think you are clear with this algorithm, right? So what are the algorithm steps? You have to read the data, initialize the number of epochs, initialize the model parameters M and C, and initialize the iteration eta, learning rate eta, and number of samples. And you have to set the iteration. So actually, if you write the code, there are the two for loops. One for loop is for inner for loop is for sample, and outer for loop is for, if you observe, outer for loop is for the iterations. There are the two for loops if you observe carefully. If you observe carefully, so this is the inner for loop for the samples. For every sample, this is repeated. And outer for loop is this one. Outer for loop is this one. For every iteration, it will be repeated. There are the two for loops or two while loops you have to use in the using programming, any programming language. If you want to write the code for the simple linear regression model training process using the gradient descent algorithm. So I think you are clear with respect to the algorithm point of view. So I want to move it to implementation of the algorithm using Python. Implementation of the algorithm using Python. Simple integration model, this one. I want to sign in into my Google Colab account. Okay. So just I am trying to write the code to explain how simple linear model parameters MNC will be updated for a particular problem. You can see the problem statement. Let's consider a sample data set having one input. These are the inputs and one output. So I want, based on this input, I want to predict the output. Based on the input, I want to predict the output. One input and one output. And my training data contains 4 samples. Develop the simple integration model with one iteration. Okay, this is for the hand calculation, one iteration, but we are writing the code. Computer will do. So I want to take the more number of iterations. Here my goal is to get the best model to predict the y value based on the input x value. So this is the one iteration I mentioned because this is the assignment I shared with my students to do the hand calculations. That's why I asked them to do only one iteration, but we are implementing in the computer so that we can go for a large number of iterations, not an issue. Computer will do the computations, right? Using the stochastic enemy sample by sample, you have to pass. So to the 0.1, 3.4, like this point. Now what we will do, this is the data set. You have to remember. So this is my data set. Okay. Done. Now actually this data set already kept in my Google Drive. That's why whatever the Google Colab notebook I have, I want to create a link between my Google Colab notebook with my Google Drive. I want to mount my Google Drive onto this Google Colab. So in order to mount your Google Drive, in order to connect your Google Drive with this Python environment, Google Colab environment, you have to write these 2 lines of code from google.colab, import drive and drive mount your content drive. If you write these 2 lines of code, then your Google Drive with this account will be connected to your Google Colab. Okay. Now run this cell. It will ask run anyway. Okay. So you can see here mounted. So my drive is mounted in the Google Colab. If you want to see your drive content, click on this folder. You can see drive. So click on this drive and my drive. All the things are available. So actually this data, what you are seeing here, this data is available in my one of the folder in my drive, that is the AI data folder. In that AI data folder, I have the sample data CSV. So this is the data that is you are able to see here. So I want to import the data from my Google Drive into this Colab environment. Okay. So before importing the data, before running the cell, first of all, we have to import the required libraries. I want to import the NumPy library. I want to import the math library. I want to import the random library. And also I want to import the pandas. So pandas library used for the data manipulations. Random is used for the random number generation. Math library for mathematical operations. NumPy for matrix operations. So just run this way. Now, if you want to read the data, so this is the data actually I have. So this data I want to read. Then what you will do, you can see the three dots. So click here, copy path, and paste here. Paste here. Then the whatever the data available here, that will be read and assigned to a variable called data. So how we read the information from the CSV file? PD. Pandas alias name is PD. PD dot read underscore CSV, and you have to note down the path. You have to paste the path. You have to mention the path from where you want to copy the information, from where you want to read the information. Okay. So that copy path, that path will be coming from here, this one. So right click here and copy path, and this is what we have. Now simply if you run this cell, then what happened? Whatever the data available in the CSV file is attached to my variable called data, and this is the data is available. You can see data 0.2, 3.4, 0.8, 4.6, 0.2, 3.4, 0.8, 4.6. The data I read from that Excel sheet. Okay. So here, few things are there. I said yesterday, outlier treatment and missing value treatment. I said right yesterday that we are going to observe here. So outlier treatment here, what I am trying, this is a piece of code. What the use of this code is, I want to know how many number of outliers are there in my data against every feature X and Y, how many number of outliers are available. I want to check that information. For that information, I write this code. So outlier initially I initialized as a null array, no information is available. And I have written a function in Python. The name of the function is detect underscore outliers underscore z score. That means I want to detect the outliers based on the z score. This is the name of the function. This is the definition of the function. And you have to pass the data. In which data you want to observe. In which data, in which feature, in which column you want to identify in which column you want to identify the outliers. You have to pass that in column information. Inside the function, I kept the threshold value as a 3. Why threshold value as a 3? I said that whatever the values are between the -3 to +3, that will be normal values. If any value outside the 3, that is called as the outlier values. That's why I kept the threshold value as a 3. Okay. And how we calculate z-score value? Z-score value is calculated as x minus mu divided by sigma. X minus mu divided by sigma. Sigma is called as the standard deviation, mu is called as the mean, and x is called as your input. Okay. Right. I think I said same thing, right? So Z score is calculated. Wait. So Z score is calculated like Z score equal to x minus mu divided by sigma. So if this value should be between the -3 and the +3, then +3, then you can consider it as a normal value. Otherwise, you can consider it as an outlier value. Okay. So from this discussion, you can understand we must know the mean value, we must know the standard deviation value. So this is how we can calculate the mean value, how we can calculate the standard deviation value for every column. np.mean of your column, it will give the mean value based on all the values available in the data column. And np.std, that is give the standard deviation in this data column. And those two values are assigned to the two new variables called mean and standard deviation. So this will give the mean value and this will give the standard deviation value. Okay. So if you want to print, you can print the mean and standard deviation value, but no use. Next thing is from the column, I want to take every value 0.2, 0.4, 0.6, and 0.8 like that. Every value I want to take from this column. And that value passing to here. That means x minus mu divided by sigma. That is the z score. This is the z score. The x value coming from the column is passing here x minus mean mu divided by sigma. That is called z score value. If the z score value is greater than 3, that means outside 3, then you can append that value as an outlier. Append that value to the outlier array as a outlier. Because if any value have a z-score value greater than 3, then that value, that I, will be a outlier. So that is assigned or appended to this null matrix or null array. Okay, this is the small function. You can use this function as it is. If you want to work for your outlier identification in your data, you can use this code as it is. Now what I am doing, I want to call this function now. How I am calling? Sample outlier x is a variable. You can use any variable equal to this function name I am writing. And in the function, I have to pass the column. Which column I am passing? X column. This is X, right? So this column of data I am passing. What it will return? So it will return the outlier matrix. It will return the outlier matrix. Similarly, I am calling the same function once again, but this time I am passing the Y column. So it will give the outliers information in the Y column, and this will give the outliers information in the X column. So now I am printing the outlier information in the X column, outlier information in the Y column. So if you run it, what it's saying is null values. That means in my data, no outliers are available. Every data is fine. So I can proceed for the next thing. Now I want to see the missing values, whether there is any missing values or not. So if you want to see the missing values, data, this is your data. This is data variable which holds the complete data information, right? So that data dot is null dot sum. That means what it will give is if any column in a data, any column has a null value, any column has a missing value, all those missing value information will be summed up and it will give the information. How many number of null values are there, or how many number of missing values are there, how many number of cells have without any information. That information will be printed here. So if you run this cell, you can see x0, y0. That means there is no missing values in the x column. There is no missing values in the y column. Okay. So this is how missing values are there. Here, this is the missing value treatment. Because there is no missing values, I don't want to much focus here. This is a code which is used for the missing value treatment. If there is any missing value in the x column, or if any missing value in the y column, then I want to fill those cells with the M1 and M2. M1 is nothing but the mean value of the x, and M2 is nothing but the mean value of y. That means in a x column, if I have any nan value or any null value, then that cell will be replaced with the mean values of the complete data, x column, mean value of the x column. Similarly, y column has any null value or any not a number, then that cell will be replaced with the M2. M2 is nothing but the mean value in the y column. This is a treatment because there is no missing values. So if you run this cell or without running the cell, nothing will be happening because there is no missing value. If there is a missing value, then only the values will be updated. Then fine. Up to here, I think you are clear, right? Now. So now data is ready. So it's I think you can go with this structure. Understanding of problem based on X, I want to predict the Y. Data collection completed. Data pre-processing, missing values are completed. Outliers are completed. Because my data is very small data, there is no need of normalization. You can apply normalization if you want. You can apply normalization. It is optional. And later data split. So data split means you want to split the data for the training and testing purpose. So how you split the data from the training and testing purpose? In the Python, you have a function called train underscore test underscore split. In Python, sklearn.model underscore selection. From here, you can import a function called train underscore test underscore split. And this function will help you to divide your input features and output features for the training purpose and for the testing purpose. So how you will this train underscore test underscore split, train underscore test underscore split. Okay. You have to pass your input features. What are the input feature? X. You have to pass your output feature. What is the output feature? Y. Now you have to tell how many samples of data you want to keep for the testing. I am using the 0.20 means 20% of data I want to keep it for the testing. Remaining 80% of data I want to use for the training. Okay. So And this function will help you to split the X and Y data randomly for the training and testing purpose. So after implementation of this function, it will throw 4 arrays, 4 matrices. One is X-train. X-train is nothing but the input features in the training data. X-test means input features in the test data. Y-train means output features in the train data. Y-test means output variables in the output values in the test data. So it will give the inputs in the training, inputs in the testing, output for the training, and output for the testing. That will give X-train, Y-train, input and output for the training data, X-test and Y-test, input and output for the testing data. So like that, we are going to split the data by using the train underscore test underscore split method. Okay. Up to here, data split is completed, right? So after that, what are the step? As per the structure of the machine learning project, what are the next step? You have to identify the machine learning model. I want to use the simple integration model. Okay. So I want to use the simple integration model. Next, what you have to do? You have to use the model training. You have to go for the model training. So model training using the gradient descent algorithm. You can start now here. Gradient descent algorithm, model training. Okay. You can see. So when you are applying the gradient descent algorithm for the model training, so first step is initialization, right? So initialization. So we have the 2 model parameters, 2 decision variables, M and C. I said already. Yeah. X and Y. Sorry, M and C are the input variables, right? So you have to randomly initialize. So M equal to random dot uniform. In the range, you can take any range. You can take any range. Minus 10 to 10, I have considered here. You can take minus 100, plus 100, minus infinity, plus infinity. That's your choice. So M and C values are randomly initialized. And eta, learning rate, 0.9, I have considered. Maximum number of iterations, I took the 10,000 because computer will do. If I ask you to do the calculate for the 10,000 folks, that is a very difficult. The computer will do, you can, no problem with that one. Maximum number of iterations, 10,000. So now, actually, if you observe, in the gradient descent algorithm, what we are trying to do? We are trying to calculate the gradients, GM and GC. Gradient with respect to the model parameter M and gradient with respect to the model parameter C. There is the dou E by dou M and dou E by dou C. So that's equal to what do you have? Minus Y minus MX into C minus C into X. Right? So I want to write a function to get the gradients. You can see gradient calculation. So define a function. My function name is gradient. What information I have to give to calculate the gradients? If I want to calculate the gradient, what information I require? Output value Y, input value X, and model parameter M and model parameter C. That's it, 4, right? You can see here. Model parameter M, model parameter C, input X, and output Y. Okay. And how we calculate the M derivative? Nothing but GM. C derivative, nothing but the GC. How we calculate the GM and GC? Minus 1 into Y minus MX minus C, Y minus MX minus C into X into X. Similarly, C derivative, that is the GC, minus 1 into Y minus MX minus C, minus 1 into Y minus MX minus C. And this function will return GM and GC or M derivative or C derivative. So you can run this function. Now, see this training process. Okay. Now, so I said the 2 for loops. Outer for loop is for, I said in the class itself, I said outer for loop for the iterations. So iteration for iter in range of maximum number of iterations. That means outer for loop will be iteratively repeated until we reach the maximum number of iterations. And inner for loop for the sample. So it will be repeated until the maximum number of samples are reached. Right? So maximum number of samples means how we get the maximum number of samples? Sample in the range of maximum number of samples in the training data. So xtrain dot shape 0. 0 means number of rows. Number of rows means number of samples. If you want the number of columns, keep the 1 here. So number of rows is the 0. Okay. So number of rows are nothing but the number of samples. So this will give the n value. That is the number of samples in the training data. So xtrain, that the training data information is available. Training input features are available. Dot shape 0 means number of rows. That is about the number of samples. So now tell me what you will do inside. Calculate the GM. That's it. GM calculation. This is the GM calculation, right? GM calculation. Agree? So how we calculate GM value? Call the gradient function and pass M value, pass C value. X and Y means for the first, whatever the sample you are taking. If the sample 1, take the first row X and Y. If the sample 2, take the second row X and Y. If the sample 3, take the third row X and Y. So that's why I'm writing. From the training data, whatever the sample you are mentioned here, that row should be taken for the X and Y. X train means X value, Y train means Y value in the training data. And which X, which Y value you have to consider based on the sample what you are passing. If the X sample equal to 1, first row X value, first row Y value. Sample equal to first row X value, sorry, second row X value, second row Y value. Sample equal to 3, third row X value and third row Y value. Like that you have to get the pass the X and Y values. Now it will calculate, it will give the GM. This is the GM. You can call it as the GM or this is your choice. So I want to call it as the GM otherwise. So GM and it is the GC gradients you are getting. Once you got the gradients, what you have to do? M equal to M plus delta M. Delta M is nothing but the minus eta into GM. So you can write M equal to M minus eta GM. That's it. M equal to M minus eta. GM means this one. C equal to C minus eta into GC. So after training process for the 10,000 epochs, I am getting the M equal to minus 3.24 and something I am getting like this. Okay, so now I hope you understand, right? So completed. I am printing the model parameter values, final model parameter values. Training was completed. Once the training was completed, now we are going to calculate the errors also. Now we are going to calculate the errors. Okay. So if you want to calculate the error, first of all, for a training input, what your model is predicting, you have to calculate. For the testing input, what your model is predicting, that also you have to calculate. So you can see this cell. Y pred underscore train, it is a empty cell initially. Later I will update. I want to store for every training input data. I want to find the predicted output and I want to store that predicted in this array. So for I in X train, that means for every input in the X train, for every X in the X train, multiply with X plus C, MX plus C. That is the predicted output. That predicted output I want to assign to here. So Y pred underscore train will have a information about the all the predicted outputs. Predicted output Y equal to MX plus C. M into input X plus C. Right? So Y underscore pred underscore train will have the all the input information. And testing data. Similarly, same thing. Previously, I'm taking the data, input data from the X train. Now I will take the input data from the X test. So that input I was multiplied with M and added to C. Because M and C values are already updated during the training process. I will use this M and C, updated M and C values. I want to use the updated M and C values. Okay. So I want to take the updated M and C values. So with that one, I can calculate M into input plus C. That will give the testing value. And that value will be appended to this array. So finally, Y pred test will give the predicted output by simple integration model with testing input data. Here, Y pred train means predicted output by the simple integration model with the training data. So you have the predicted output. This is the predicted output in the training. It's the predicted output in the testing. But where we get the actual outputs for an input, for a training, where we will get the actual outputs for the testing, where we will have the actual outputs for a training and testing. These are the predicted outputs, right? These are the outputs predicted by your model. But where the actual values are available, those actual values are available in Y train and Y test. Y train contains the actual outputs on the training data. Y test contains the actual outputs on the testing data. Okay. Now I want to calculate the errors. If you want to calculate the errors, you can use this piece of code. So you can write a code from the scratch also, or you can use the libraries. I want to calculate the mean square error. I want to calculate the mean absolute error. You can get this mean square error, mean absolute error from the sklearn.matrix library. Now, if you want to calculate the mean square error, MSE, then call this one mean square error, pass your actual output and predicted output. So it will give the mean square error. If you want to calculate the mean absolute error, so then call this mean absolute error and pass the training output, actual output in the training data and our predicted output with the testing data. So if you run this cell, so it will give the errors here. So you are getting the error somewhere like 2.3, 1.4 like that. So this is not at all acceptable. You have to still reduce. You have to still reduce your model parameters. You have to update your model parameters to reduce the errors further. Similarly, the testing performance. In the testing performance, you have to pass the actual output in the testing data and predicted output of the testing data. And here also actual output in the testing data and predicted output in the testing data. If you want to calculate the mean absolute error or if you want to calculate the mean square error. So if you run this one, you want to calculate the what happened here? Wipe test is not defined. So these are the errors I am getting with respect to the testing data. So if you want to calculate the mean squared error MSE, call this mean squared error function and pass the actual output either from the training or testing or predicted output from the training or testing. For which data you want to calculate the error, you have to pass like this. So if everything is fine, if you assume if the errors are happy, then you can deploy the model like this. Deploy the model. So x equal to input, enter the x value. And the text value is multiplied with my model parameter M, add the bias parameter C, then it will give the predicted output. So if you run this one, if I give the 0.2 here, so it will give the value something like a 5.56. 5.56. Okay. This is the input and this is the predicted by the machine learning model. But I'm not happy with this one. So we can still tune your model parameters or learning rate, then you will get the some good values. So maybe reduce the learning rate and so still not happy with this one also because so 5.5 I'm getting. Actually, actually for point it should be 3.4, but it is giving some larger value. So we need to update these model parameters further. We need to update the model parameters further, or sorry, we need to update the, maybe we can increase the number of epochs or we can further decrease the eta. So I'm getting some other values. So still you can see whether you are getting the value nearby or not, something 0.2. So don't expect that every time your model will correctly predict your output. So don't see, if you have a deterministic approach, don't look for the machine learning. Machine learning models will provide output close to your input, not exact, output, your predicted output will be close to your actual output, not exactly equal to your actual output. So you have to play with your the model parameters. Okay. So this is how we can we can write the code using the gradient descent algorithm updation of a model parameters of the simple linear regression model. Here I am not using any library to apply the simple linear regression model. So in the tomorrow's session, I will take the library from the Python, how we use the simple linear regression model. So I will use that one. So I will take the linear regression model library from the sklearn models, and using that library, then you no need to write this piece of code. You no need to write this piece of code. It will take care of everything. So here we are writing this piece of code because we are writing the training algorithm by ourselves from the scratch using the gradient descent algorithm. But tomorrow, when you are using the libraries, you don't need to calculate the gradients. You don't need to write these for loops. It will take care of everything. So that we will discuss in the tomorrow's class. Okay. So please let me know if you have any questions.